Hello and welcome back to another video. So today we're going to have a look at how to get Pfsense working on VMware without a vSwitch. So the idea is that what we're going to do is we're going to get our physical NIC and we're going to essentially pass it through into Pfsense. Well, why do we do that? So the reason why we want to do that is because we want to have control over the NICs so that way information comes straight into them, and that we can do the processing on Pfsense itself, thus bypassing the vSwitch, so that way we don't have any sort of delay in the processing. It's all directly off the NIC. So what we're doing is something called a direct pass-through. Now, a direct pass-through essentially means that any hardware that you have is being passed through into the operating system directly. So the best way to think about it is, for example, say I have, I don't know, this Pfsense device. We use them in Britain for banking and that kind of stuff. But this Pfsense device, which is in my hand, rather than saying, oh, it's a container, so in other words, rather than saying it kind of lives, let's see, oh, here we go. Right, let's use this bag as an analogy, right? So the way the virtual machine would see it would be something like this usually, right? So you have your virtual machine, your hardware's down here, it'll have some way to interact with the hardware and then present itself to the world, right? What we're saying is, well, rather than it being in there, as in its virtualized state, in other words, its containerized state, we want it to be kind of alongside the virtual machine, so that way it can do other functions. So that's what we mean by that. So you might be thinking, well, what's the point of this? Why would you do something like this? And the main reason is because, well, I've been thinking about getting a router which is scalable, essentially. So a scalable router, so I can have as much RAM as I want on it, as much CPU as I want on it, and then on top of that, I can even give it 25 gig, 50 gig, 100 gig NICs that I can pass through directly. Now, VMware does support it, that you can get VMX on Pfsense. I've just not liked it for my type of setup, because what I ultimately want to do is I want to replace my router with that particular virtual machine of Pfsense. And I've actually managed to do it in my own time. If you've seen my videos beforehand, you'll have seen that I have managed to achieve this. So enough jibber jabber, let's get into the meaty stuff. The first thing that you want to do is bring up our Pfsense, right? So Pfsense is coming up right now. Let's have a look. So we've got 10.5. Okay. And over here, I'm just going to log in to my client, my vSphere client. Now, of course, you don't have to be limited by Pfsense at all. I wouldn't recommend using Pfsense. Sorry, I wouldn't recommend using VMware. I was going to say Pfsense, but I wouldn't recommend using VMware at this moment in time. And the reason why is because they're changing the licensing model, which makes things a lot more tricky. The reason why I like to use VMware is because it has quite a well-documented Terraform library. The one which is coming up nowadays, I would say, is XCP. So if you don't have Pfsense, don't feel disheartened. Sorry, if you don't have VMware, I keep getting this mixed up. If you don't have VMware, don't get mixed up. Yeah, don't get mixed up by not using VMware. You can use XCP, you can use other type of hypervisors as well, like Citrix Zen, I think is another one which seems to be grabbing some traction. But the main, at this moment in time, I would say XCP is probably your main one. That's the one that you want to be looking at the moment. I still have my perpetual license running on VMware, so I'm using VMware for this demonstration. But of course, feel free to replicate this in XCP. I know that there's a person on XCP at the moment. I think his name's Danilo. I think that's his name. He makes a Terraform wrapper that you can use alongside XCP, and it's really, really good. So if you know any Golang, go and support the project. I highly encourage that you do, because that template is currently being manufactured by one guy. So one person is making the Go code, the Terraform provider. So if you know any Golang, please support that project. It would help so much in terms of the contribution. to that project and other people as well who use XCP, it's a night and day kind of shift. So, moving on. So I'm just going to check my memory and storage at the moment. So I've got 63% and 81%, which is fine. That's more than enough than what we need. I like to give this particular machine 30 gigabytes of memory. I'm going to give it about 4 CPUs, maybe even 8. I think I'll give it 8 because I like 4 cores. I think that's probably more than enough. Maybe even 60, maybe 16. Let's be generous. We're only using about 1% of the server. We'll use 16. Why not? I have got another Pfsense machine on this box, just to prove my point that it is possible to do. So I'm actually using this machine at the moment to do all my routing, and it's, of course, it's got 16, it's got, you know, that kind of thing as well. Now I have to be quite careful here because this is going to be slightly intrusive to my network, but the reason why it's not going to be in this case is because I'm using a second NIC, which is going to be my fiber operating NIC. Okay, before I get into this particular video, what I want to say is that the prerequisites are that you want to have kind of 2 NICs initially, or if you have a separate network, use that and use a VLAN which you're not using. In my case, I'm using VLAN 1 as my precursor, and this is the VLAN which I dedicate DHCP addresses to provision other machines. So in other words, the DHCP pool is the pool which you have, and then you say, right, okay, I want to give it an IP address. So for those of you who don't really understand what I'm talking about, let me put it another way. I have some post. Let's say, you know, I have some post, and I want this post to go to my next door neighbor. Yeah. So I have to tell the server where that is. Now that's more DNS, but to put it into perspective for DHCP, I would say it's a bit like saying, I don't know what my address is. Can you tell me what my address is? And then that's more DHCP, right? Because now we're saying, right, okay, I have all these addresses. I'm going to give you a single address, so that way I know where you are based upon your IP address. So that what that's saying is like, okay, I want to go to Manchester, but I don't know where I am. I need some way of getting there, essentially, and that's kind of what DHCP does. It says, right, okay, I know that when you go to Manchester, send me some information so that way I know that you're there, and then I will get it back. So that process is called DORA, which is discover. That process is called DORA. I'm trying to remember why we call it DORA. I think it's called discover something address. Let me just double check that because I don't remember, but I do remember the process is called DORA in DHCP. And there is a reason why it's called discover, offer, request, acknowledge. That's it. Discover, offer, request, acknowledge. So we discover what's there. We send out the offer, receive the offer from the request, and then we acknowledge it for an acknowledgement. So these are all based upon the headers in DHCP. So, cool. Right, so what do we do? What's the process? Okay, so now that we've got all the prerequisites out of the way, and we've got our VLAN set up, we've got all that kind of good stuff. What you want to do is you want to create the virtual machine. We go to create new virtual machine. I'm going to call this Pfsense 2 because I already have a Pfsense machine. So I'm going to call it Pfsense 2, and we're going to call it other, and then we're going to call it FreeBSD 14 or later, and that depends on the version of VMware which you have. You may not have 13 or 14 or later, but essentially that's what we want. We'll go to the 64-bit version because that's what Pfsense supports, and it's quite useful for us. Now I'm going to select my data store as being the one which I have here, which is VMFS6. Click Next, customize the settings. I want 16 CPUs on this, 30 gigs of RAM should do, and we'll use something like 20 gigs of hard disk space. We don't need much for Pfsense, not the way that we use it. We don't use squid proxy or anything like that, so that's fine. Just gonna wipe my nose there for a second. There we go. And we're gonna give it about 30 gigs of hard disk space. The SCSI controller, I would say go for the LSI Logic SAS one, because that's usually the fastest one. Don't need to worry about the USB controller. Now, this is where it gets interesting. We have network adapter 1. Okay, network adapter 1. And what we want to do is we want to say, get rid of that. We want to have our drive set to the Pfsense ISO from our data store. Now, on my data store, this is slightly different because in the VCSA, it comes up saying that I have another drive where this sits, which is fine. But for our purposes, Pfsense 2.7 is, 2.72 in fact, is absolutely fine. Let's click next. That looks good. I'm going to click finish for now. So clicking on the Pfsense 2, what I want to do now is I want to do something called a PCIe pass-through on that virtual machine. Again, going back to that analogy that we said earlier, what we're doing is that we have a NIC, and what we're saying is that we want the virtual machine to use that power of the NIC directly without any other intrusion. So in other words, without any other virtualization layer on top. So if we go to edit the settings, we should be able to now see what kind of adapters we are able to pass through in terms of our physical devices. So let's add another device, and let's click on PCIe device and see what we have. Right, so here's the problem with this particular setup. The first thing that I have to do, and the problem that we have here, is that we have two Ethernet controllers. So this is not actually an Ethernet controller in my X710, which is my copper-based network, which is why it's called 10BASE-T. But essentially what's going on is that we have two ports on the controller which can be potentially passed through. And I'm already using that in my Pfsense box, which is why I'm not going to use them here, because my copper network is being controlled by a separate Ethernet NIC. So if we cancel that, what we want to do instead is we want to send in my fiber NICs. So what do we do in that case? Well, we go to manage, and here we have something called hardware, right? This is the hardware list that is available to us. So anything that you've put into that server for your virtual machines, or more specifically, the physical hardware itself will be represented in this table here as PCIe devices. So in my case, this is going to be a separate NIC. So I need to look for that and figure out what it is, because even I don't remember what I put in here. I just remember it's there. So I'm going to have a little look and see if I can find what it is. And here we go. We have the E810C for SPF. Okay? Right. So here's where it gets a little tricky. What this is not the controller itself, but because this particular NIC has IOMMU separation, so in other words, it has the ability to separate each individual port, right? Each port individually. That's why I get 4 addresses in the table. Okay? Starts from 0, goes to 3. That's a list. Okay, cool. So what I need to do is do something called pass-through. Not SRIOV, but pass-through. Okay. In order for it to be passed into the virtual machine. So here we go. This is what we're going to do. We're going to go here. Now, of course, I don't expect everybody to have an 810C. You can do this with any Ethernet controller, if you want to pass in the controller directly, that is. Or you can do it with any particular Ethernet controller which has separation for ports. So in my case, and there's a specific term for this, if I look at E810, right, from Intel, so that particular, this is the one that I have, which is the XXVDA4, which is the direct attached version. In here, there's a function which allows you to do, here we go, flexible port partitioning. I think that's the technology which Intel uses, which allows you to do SRIOV and divide your physical Ethernet devices into multiple virtual ones. That's called NFV, right, called Network Virtual Functions. But essentially, what we want is to partition the ports so that way they are individual. That's the reason why we look into that sort of mode. And of course, it's got some extra stuff in here like RDMA2, which is awesome, intelligent offloading, and then storage over Ethernet. So we get that flexibility. In my case, I'm using a 10 gig NIC, but I can easily upgrade to 25. Sorry, I'm using 25 gig NICs in this one because I'm waiting for my splitter to come. So that's the 100 gig to 25 gig adapter, and that hasn't come through yet. Check out fs.com if you're looking for direct attach cables, or you're looking for cables and SCP modules. fs.com, really good company. I'm not sponsored by them. I wish I was. fs.com, if you're looking at this video and you want to do a collab, like, hit me up, because your products and your services I think are pretty awesome. I'm yet to test them, but I'm pretty sure they're going to work. And if not, your customer care is really, really good. So I really have no issue really to say that they're not going to work. I think they will. Cool. So yeah, that's what that's about. So I'm going to go there and just click on enable for the pass-through. There we go, toggle pass-through. That's what I was looking for. Toggle pass-through. And if you haven't rebooted the server, so in other words, this is the first time that you're passing through a device, you will need to reboot the server. You will get a message saying that you need to reboot the server, and then toggle the pass-through. Okay, cool. So now let's go back to Pfsense 2, and what I'm going to do is I'm going to pass through every single NIC. That's 810C. And the way that we do that, as mentioned before, is just add a device, PCIe dynamic devices, and we should get 4 separate NICs there. Now, it can be a little funny. I have seen VMware be a little bit funny in terms of the controller, because it can give you 1. Now, I'm not sure if you need VCSA in order to bypass that. So what I mean is that it can show up as 1 controller as opposed to 4 separate ports, which can get quite annoying. It depends on the card that you use, and it depends on whether or not you have VCSA. In my case, I do have VCSA, and check out my other video if you want to see how I installed it and how I got it working, so that way you can have Terraform functionality as well. But in my case, it's just come through directly. You may need to restart the server in order to see it, but those are the couple of things that I can think of. So in other words, if you don't see it in your VMware settings, make sure that you've removed the default network that's part of VMware. So in other words, the default network that was there. So that way you're only passing in the PCIe devices. And then the second one that I'd recommend is, if you still can't see it, manage the machine using VCSA, and that should allow you to see it a little bit more clearly, because it may just be hidden in that sea of options. So that's the thing that I've noticed and I came across when I did my practice, and it may be the same for you. So that's what I would say if you're trying to do some troubleshooting, trying to figure things out. I hope that saves you a bit of time there. So I'm going to add all these in, and it's just the same process. You can do this in Terraform if you want, and leave a comment down below if you'd like to see that, because I'd be more than happy to show you through how to use Terraform templates to do things like pass PCIe devices. If you just want a bit more flexibility in terms of creating virtual machines, now that I've got a little bit more of an understanding of how for loops work in Terraform through the key value pair system, I can definitely show you that, and even use things like dynamics as well, which makes things very, very cool if you're trying to provision more than one machine. And it's great for industry as well. So if you want to see that, like how that would work in an industry type setting, yeah, go for it. Leave a comment down below, like and subscribe as well. So back to the video. We have 1 PCIe device. 2 PCIe devices. Let's go for the 3rd one. An NVMe controller. Which we don't have. 3 PCIe devices. 4 PCIe devices. Very nice. So let's connect and let's save that. Right. Moment of truth. Did he do a Danny? Or did he get his eternal wisdom? Find out. After this message, this video is sponsored by nobody. Just me. So let's go and see what we have here. Right, yeah, okay. Interesting. So, one thing I forgot to mention is you need to reserve the system memory when doing this, and I forgot to do that, and VMware has rightly gone, what are you doing? Why aren't you reserving the system memory? I'm like, yes, okay, I forgot. It's okay, VMware, I forgot. I'll come back to you. Right, so the way that you do that is you edit the settings, and then in memory, what you want is you want to do something called reservation. And here's where it gets annoying. Now, for whatever reason, and I do not know why, I don't know why it's grayed out. It's grayed out for some reason. I haven't figured out how to get this back. On my setup, it just is, and I believe that's because of VCSA. But if you see that, don't lose hope. Install VCSA, and you'll get it. That's the only way that I managed to get around it. Actually, maybe there's another way. Just before we do that, I want to just check something. Let's delete that. I'm going to delete that. I'm going to go back to where I was and see whether or not we can create the virtual machine again and preserve the system memory. I hope that we can, but if not, then we may be forced to use VCSA. Let's see. We want other 64-bit. There we go. Next. 16 CPU, gigabytes, 30 gig, OSI logic, get rid of this, want that on, yeah, see, reserve system memory, we can't reserve system memory. I don't know why, it's just blocked. Right, okay. So we'll be right back. Alright, so, we're here in the VCSA, so the vSphere client, in fact, that we set up earlier. And this is the only way that I could get it to work. I think if you have VCSA, it just doesn't allow you to do it. I'm not sure if that's a bug or a feature or whatever the frick that is, but yeah, essentially we got Pfsense 2, which is orphaned. We want to get rid of that because that's the old machine. The old machine. Alright, let's make a new machine. And I'm going to create a new one. My new virtual machine is going to be called Pfsense 2. Okay, I'm going to stick it into the current data center. Same cluster. Yep, just in that. ESXi8, yep. Other, and then we're going to call it the same, which is 14. Somebody's ringing me there. Next. 16 CPUs. 16 CPUs, we're going to do 30 gigs of memory. Hard disk space is 30 gig. And then we're going to take this part out. So this part is not needed. We don't need the new network. And that's fine. Memory we can now reserve. Yep, see what I'm saying? This is weird. I don't know why it allows us to do that in here, but in the other one it doesn't. I'm guessing because it wants it's fully controlled by VCSA. But I think if you don't have VCSA installed, it should work with memory reservation, so you should still be fine if you don't have VCSA or have a license. So I wouldn't worry about that too much. And then for our disk, what you want is we want to have data store. That's my data store. Now for me, this is in a weird place. Oh no, it's not. It's there. Okay, cool. And that's where it is. Next. And that looks good. We just need to add PCIe devices. And we want one Ethernet controller. There should be 4. Huh. That's what I was saying. This is where it gets weird. This is wrong anyway. That means that there's one. Okay, let's have a look. So we don't have... So logic SAS, which is correct. Connected to data source, the data store, which is fine. IDE, IDE. Other additional hardware. Okay, next. Finish, but don't power it on. We want to add our devices, but I know that they've been passed through. Let's have a look. And it's PCIe. Okay, I see. Okay, yeah, so there's 3 pages here, that's fine. Yeah, this is what I mean. Sometimes it's a bit weird. It doesn't quite... So 3, 2... Ah, there they are. Okay, so I see 3. Okay, okay, that's fine. So 1, so 0, 0, 1, 2, 1. Wait. Oh, alright, okay. Select. Machine is unavailable PCIe pass-through. Yeah, okay, that's fine. Don't care. Because we're not interested. Next, we want 1. So we have 0, 1, okay. 0, 1, 2. So 0, 1, 2, and then we want 3. Which is here. Well, it was there, so number 2, isn't it? There you go. 0, 1, 2, so it should be 3. Yep, 0, 1, 2, 3. Okay, cool. And that's that. Okay. And now what we're going to do is we're going to power it on and see if it does anything. Because it should be fine now. Alright, here we go. So that's loading up. Now the problem with this is that I don't know which actual NIC belongs where. So I don't actually know which one's 0 to 4. But if I think about it, right, what does that mean? It means that the one which is on the far left, I believe. Is it left? Yeah, I think it's the one which is on the left, goes from 0, 1, 2, 3, 4. I made a video about this where I explain how that works. It's on the troubleshooting one for the VM. That's why I wasn't getting DHCP addresses, and I go into more detail there. But yeah, if you haven't seen that video, just have a look at that video. It will explain more detail what my logic is for this video. So let's install Pfsense, AutoZFS. I like ZFS, so I'm going to use AutoZFS because I like ZFS, and I'm using NVMe, so why not? Next, we don't need any redundancy because we're bad A's. I'm going to say bad aces. Right, okay, pool name Pfsense here, that's fine. 4K sectors looks good. Encryption, because why not? I mean, we're not in an industrial environment setting, but yeah, if you want encryption, use mirror swaps, use encryptor swaps, all that good stuff. So I'm just going to proceed with it as is. I don't need any redundancy because I don't know why I don't need redundancy. I just don't need redundancy. So don't ever do that in industry, by the way. Don't ever do that in industry. That's asking for trouble. Okay. Are you sure you want to destroy it? Yes! Alright, let's reboot. Let's see what happens. It should give us 4 E810s as interfaces. If the guy that I bought it off sent me good cards and not duff ones, then yeah, it's just going to be good. Alright, 2, 1, let's boot, let's see what we got, and we should have 4 interfaces there now. All being well. Takes a minute for it to boot. It needs to do this cam business. Dev D, and we have 4 interfaces. Yeah, exactly what we want. Should VLANs be set up now? The answer is yes, you should set up VLANs now. So any VLANs that you have should be set up at this point. So I'm gonna just read this. The best thing to do when you set up Pfsense is read the prompt and try to understand the prompt. So should you set up VLANs? Should VLANs be set up now? What that's saying is that do you want to set up virtual local area networks at this point? So what's a virtual local area network? Well, it's a segmentation from the physical, right? Not a good explanation, but allow me to explain. So what we're talking about here is that if you have a network, right? You can have a network which looks like not this. This is kind of important. This is all important. Let me see if I've got a bit of paper. Let me see if I've got a bit of paper. We can say. Okay, like this, right? So you've got a bit of paper like this, right? Okay, so your network can be like this, where it's like whole list of addresses, right? Everyone's shouting at each other, so we can say like, you know, this is Bob, this is Alice, this is Raj, this is another peep, another peep, another peep, blah 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 blah, right? So on and so forth, right? So let's say that this is D, and he wants to talk with A, call this B, AB, right? So DAB, like digital radio, right? So you've got a couple of people there, right? Now, if all these people have megaphones and they're trying to talk to each other, right? What you end up with is something called collisions, whereby everybody's trying to talk to each other, and that is nonsense. Right? Why would we want a room where everyone's trying to talk to each other at maximum volume? It's silly, right? What VLANs does, it says, right, D and A, right, D and A, so these two people here, you are in a separate room. Okay? So you're in a separate room, and everybody else will be in a separate room. So that's the concept of VLANs. Essentially, you're saying, right, I don't want you to broadcast to B here, right? You can't see B because you're locked in a room, right? B can't see you because you're locked into a room. That's the nature of VLANs, essentially. You have, right? So in order to get B to see D and A, we have a mediator, right? We have something called an inter-VLAN. Okay? Now, in inter-VLAN, what happens is you have given, essentially, B access to the room, or basically access to communicate. So if you think about a radio, like an old two-way radio, it's like B, A, and D are on the same frequency, so they can communicate. And you're more or less on the right lines there for inter-VLAN. And how is that happening? Well, we use something called a tag in VLANs. Now that tag, right, if it's tagged, means that only people who possess that tag can communicate with that particular service, right? So if they have a tag, in this case, right, then you're saying, right, okay, you know, if you think about a tag in prison, only these 3 can communicate based upon that tag. And you have something called untagged as well. Now, untagged just means that, okay, you are not setting up a trunk, essentially. That's what it means. It means that you're not setting up a trunk connection. So if you're doing a server-to-server, it's not a server-to-server, it's an access, which means that it's more like a computer. Okay? So tagged is a trunk. Untagged means access. So if you're like a network administrator and you get confused, I hope that helps you. Essentially. But all it means is that we're adding a bit of extra information to say, right, okay, these 3 can communicate. So There may be like a bouncer at the door. So if you think of like a bouncer at the door, that's similar to kind of the concept of inter VLAN. You're saying, right, okay, you're on the list and therefore you can come in. Bit similar to ACLs, but in the analogy, but it's not. It's just saying, right, okay, if you have the ability to communicate with each VLAN, which therefore you will need an ACL, which is called an access control list, which is like the bouncer analogy, and the name is down, then you can communicate. So yeah, it's essentially that. Okay, so don't feel confused if like, you know, you don't really understand it. All you need to understand is like two people in a room, they're locked in the room through the VLAN, and then you have an external party that wants to come into the room. A Pfsense will sort that out for you, as long as you give it access. That's long and short of it. Okay, now that we've got the VLAN explanation out of the way, do you want to set up VLANs? I want to say yes, because I want VLANs. Enter the parent interface name for the new VLAN. So what that means is, how do I explain this? What's happening here is something called router on a stick, whereby, well, you can set it up in router on a stick, but essentially what is happening here is that you have one interface, which is the parent, and then you can have 4,096 different VLANs attached to it. Okay, now why 4,096? The reason is because it's a, is it a 16-bit frame? I think it's called a 16-bit frame, if I remember correctly. I think it's 16-bit, where you get that amount on, it will give you 4,096 essentially. So you can put 16 bits of information in. That's the detailed explanation. But essentially, all you need to know is you have one pipe, which is your physical pipe, your physical network, your physical bit of cable, and then underneath is your virtual. Okay. Now with the virtual, it hangs off the physical, so you have to select which one is physical, so that way the machine knows how to set up the virtual. That's all we're doing here. Pretty much that. So what we want for our parent, I'm going to say... Right, what should I do here? Because I need two, right? I need a WAN and a LAN. A WAN and a LAN. So I want 0 to be the LAN. Sorry, to be the WAN. Because in my setup, the one which is furthest away, so in other words, the one that's furthest away, on this side, that port should be the WAN port, because I'll be bringing that fiber cable from the media converter into the system. So I'm going to be doing that. I'm going to call ICE1 as my LAN interface. Okay. Now enter the VLAN tag. Now this is what we were talking about. 4,094. Now it is 4,096. 2 are just reserved. 2 tags are just reserved in this case. Some switches go up to 96, I think, but we don't really use them. Don't know exactly why. And well, actually, I might do. I think it's because they start from 0, if I remember correctly. There's programming which makes it start from 0, if I remember correctly, and then 1 is reserved anyway because it's your default VLAN, right? It's the default VLAN. So 1 by default everybody can communicate with, because by default you communicate on VLAN 1. Every single device on the planet has VLAN 1 enabled in it in networking. By default, right? It's there by default. So when you get equipment, even if it's not industrial, by default it will be on a VLAN 1. Unless you set it up onto a different VLAN, which is the tag and untag business. So, enter the VLAN tag. Right, this is going to be interesting. What should I give it for a VLAN tag? Well, I know that 10 is my management VLAN. So let's give it 10 as a means for management, right? By default, I already know 1's there, so it should be fine, right? Enter the parent interface name for the new VLAN. In my case, that's management. Okay, invalid interface name. Oh, didn't I do that before? Oh, if it's finished, right? Okay, so we're finished. And when I thought it said interface name, I thought it meant name of the virtual interface, which is why I made that mistake. So let's click next. And here we go. This is what I was talking about with the tagging. So the physical NIC is ICE1, the virtual is 10, and we have VLAN of tag 10 to parent interface 1, right? Good. So now it's asking for a WAN interface. Now my WAN interface is going to be ICE0. ICE0. Now it's not going to find anything for auto detection. You can use auto detection if you're not using fiber as well. You can use the same thing applies to the physical copper cable, which is your RJ45. It's fine. So I'm going to say that's ICE10. ICE0, I mean. ICE10. ICE0. Enter the LAN interface. Okay, so my LAN interface is going to be ICE1. Why ICE1 and not ICE10? Because this is the interface which will carry the default VLAN traffic, which is VLAN 1. Right? By default, I want to be able to administer the server without having to mess about with the VLAN settings, and that's the reason why we have the LAN interface. So that way, if I'm making a whole new network, I can just plug it in and then remove that VLAN 1 at a later date. And that's the kind of best practice, if you will, for setting up this kind of server in an environment. So, what did I say? It was ICE1, right? Okay, ICE1. That's going to be my LAN interface. Optional interfaces, we don't need one for now. And yeah, there we go. So we got ICE0 as WAN and ICE1 as LAN. Yeah, let's proceed. And it's not going to find anything on the WAN interface. I'm not expecting it to, so that's fine. And we can add different VLANs in. VLAN 0. Changed name to ICE10. I'm not sure I like that. We'll have a look at that later. But there shouldn't be any IP addresses. It should just say there's nothing there because nothing's plugged in, which is correct. So what we need to do is we need to create the IP address pool. And once we create the IP address pool, then we will be able to rock and roll when we put in our DACs, our SFPs, our RJ45 cables in, and all that good stuff. We should be ready to rock and roll. Now, this is not going to interfere with my network at the moment because I'm setting this up on a separate network. And if you're doing this as well, I encourage you to do it that way, so that way you don't lose network connectivity, and then you'll be fine. Essentially, you don't want to bring down your network while you're building a new one. So, have a backup contingency plan in place. Use your current existing settings to manage your VMware settings. And I think if you have a VMware setup, you're pretty much clever enough to know that. But yeah, I would just say, just be careful on that front. See, and it's already done it for us. We already have the 192.168 there as well, so that's pretty much complete. We can go into a bit more messing around in terms of setting up the VLANs, and I think that's pretty good place to start as well. I probably should set up my LAN setup, so you can kind of continue watching the video here. If you have enjoyed the video, please like, comment, and subscribe. I'm new to the whole YouTube. I'm kind of new to the whole YouTube. See, I say NewTube. NewTube. Yeah, let's call it NewTube. I think that's what it should be called, right? I'm gonna call it NewTube. I'm new to the whole NewTube concept, so yeah, just bear with me on the videos. I'm still getting them sort of hammered out. I'm getting them sort of fixed. I'm getting them all sort of in the right space. Like, I only do this on the weekends. I don't really get much time to do it on the weekday. Like, I'd love to do this as a weekday job, but I can't at this point in time, unfortunately. But with your support, maybe we'll get there. I don't know. Just, if you like my content, you like my content. If you don't, suggest improvements. I'm all here for improvements. I'm sure there's things that we can do. Right. Yeah, so if you want to stop here, because this is pretty much done, you can. If you don't want to and you would like to see a bit more in terms of the VLAN So, let's look at the VLAN setup. We want to do some more VLANs. Let's see. I think it's number 1. Right, number 1. Yeah, here we go. Should VLANs be set up now? Yes, because I do want to have a separate... Do I want a separate VLAN interface for wireless? Yes. Yes, I do. Will it be possible to do with a breakout cable? I do not know. If anybody knows the answer to that, like leave a comment, because I'd love to know if that's possible. Yes, VLAN should be set up now. Warning, all existing VLANs were cleared. Oh, why? Why? We just set it up. But alright, fine. What was my parent? ICE 1, wasn't it? Yeah, ICE 1. ICE 1. V1 10. Enter the parent VLAN for the new VLAN. Okay, ICE 1 8 ICE 1 5. So we've got 8 1 5 12 13. I think I need 12 13 4. Okay. ICE 1 12 ICE 1 13 ICE 1 5 ICE 1 4, and that's it. So we got 10 8 5 4 13 12. Yeah, I think that's most of my network. There's probably more in there, but that's most of my network anyway. Oh, there's 9 as well, which is the Wi-Fi VLAN. For my case, it won't be for your case, but it's for my case. Enter the interface name. My interface name for that is ICE0 for WAN. Enter the LAN one, which is ICE1. Optional interfaces aren't there. Would you like to proceed? Yes, because that looks good. I'll think about my Wi-Fi one. I'm not sure about my Wi-Fi one just yet. But yeah, I can have a look at that at a later point, I think. The reason why is because I've only got 1 NIC just now, and I need 4. I need the other 3 essentially, but yeah. Okay, cool. So that's done. That is done. How do we know if it works? Well, you have to tune in a little bit later on, but I'm pretty sure it does, because I'm looking at the settings now and they look pretty good. And the way that you check it is that you plug this into your switch on VLAN 1, make sure that you have VLAN 1 on your switch settings, and then plug it in your either side as DAC or RJ45, depending on the way that you set it up. So I've got an Arista switch, and then on my Arista switch I'm going to be using the 100 gig breakout to 25 gig. Bung it all in, and it should be all fine and pretty much ready to go. So yeah, I hope that's helped, and I hope that you've learned something new. Cheers, thank you for watching. Comment, like, subscribe, all of that good stuff. Really appreciate your support, really appreciate your help. Really appreciate the support, really appreciate your help again, and yeah, hope to see you again soon. Cheers.